So in this video I'm going to be introducing you to simultaneous equations. This is more of a recap video again because you should know this from GCSE, and I just want to recap it because it does come up in the A-level spec once again. However, you don't have to show it algebraically as much because I shall show you in a minute. There's a button on your calculator that can do it for you. So to begin with, I shall essentially start off with some basic stuff, and then we'll move on to some quite complex stuff looking at simultaneous equations. So if I have the equation y equals 2x plus 5, for example, and I also have the equation y equals 3x plus 10, and I wanted to find out the x and y value for this, there's two ways. Way one is to label them up, and I can put 1 equal to 2. So I can say that 2x plus 5 is going to be equal to that 3x plus 10. So I shall take 2x from both sides to leave us with 5 is equal to x plus 10. Take 10 from both sides, so I'll get x is equal to minus 5. I'll sub it into, so sub into 1, okay, sub that in, so I get minus 5 times 2 plus 5, so it'll be minus 10 plus 5, which is equal to minus 5. So these lines intersect at the point minus 5, minus 5. So if I draw pair of axes, so minus 5, so they intersect here. Got one with a positive gradient of 2, so something that looks like that maybe. And then we've got another line with gradient 3, but also goes through 10. Okay, so we've got a line that goes approximately like that. And where those two lines cross is minus 5, minus 5. Alright. So that is how we can do basic simultaneous equations. Alright, so it's linear equations. Now, if the equations aren't linear, so if I still have that y equals 2x plus 5 line, but now I introduce x squared plus y squared equals 25, I want to know where this line intersects this circle. Now, I know what y equals, so I can sub y into there. So sub 1 into 2. So I get x squared, now plus y squared. Now y is 2x plus 5, so it's 2x plus 5 all squared is equal to 25. So I want to expand that bracket out, so we'll do, I'll use the group method, why not? We get 4x squared, 10x, 10x, 25, so I get 4x squared plus 20x plus 25, x squared plus 4x squared plus 10x, no, plus 20x plus 25 is equal to 25. Okay. Now, solving that even more, so I can cancel this down, I get 5x squared plus 20x is equal to, take the 25 from both sides, will be equal to 0. I can factor 5x out of the bracket, and I can put x plus 4, which is still equal to 0. So if I expanded that, I get back to that. So that will tell you that either 5x is equal to 0 or x plus 4 is equal to 0. Well, if 5x equals 0, then x plus equals 0. Or if x plus 4 equals 0, that means that x minus 4. Now you always sub back into the linear. So 2 lots of 0 plus 5, 2 lots of 0, 0 plus 5, so we get y is equal to 5. 2 lots of minus 4 is minus 8, plus 5 we get y is equal to minus 3. And they are my 4 solutions. So we have coordinates 0, 5 and minus 4, minus 3. So the circle and the line intersect at those 2 coordinates. Pretty simple. It's just now using a bit of algebra and expanding a bit of brackets. So, okay. So it's not too much difficult to deal with those. But it looks difficult just because I've got a quadratic in there. Okay. Now you might end up with a linear and a quadratic. So I have y equals 3x plus 7, and I don't know, y equals 2x squared plus 4x plus 9, for example. I'm making these up on the spot. Same, so I can put them equal to each other. Okay, put them equal to each other. Now I can take 4x from both sides. I shall end up with... In fact, no, let's take the 3x first. Let's do the 3x. So I take 3x, I get 2x squared plus x plus 9 will equal 7. Take the 7 from both sides, so I get 2x squared plus the x plus the 2 is equal to 0. Now the next stage will be to solve this quadratic. I don't think it's factorable, so we will get decimal answers. And I only want to find the x coordinate of intersection here. I can't find the y. I can, but it'd be a bit of a mess. So I'm only going to find the x coordinates just to make this video a bit smaller. Okay, now I don't fancy completing the square on that, that'd be nasty. So we shall use quadratic formula. So we're going to have x equals minus b, so minus 1, so minus the square root of b squared, so 1 squared, minus 4 ac, all over 2a, so it'll be 4. Got minus 1 plus or minus the square root of 1 squared, so 1, minus 4 times 4 minus 16, 1 minus 16, all over 4. And we end up with minus 1 plus or minus the square root of minus 15 over 4. Now, the reason why I don't want to find the y coordinate is for this reason. I can simplify that down if I'd like. But however, we're going to get into what's called complex numbers. And we cannot solve for something where the discriminant, the b squared minus 4ac. So if you've done the discriminant before, you'll know the b squared minus 4ac can be, if it's less than 0, it has no real solutions. It only has complex solutions. If it's greater than 0, so greater than 0, it has therefore 2 distinct roots. And when it's equal to 0, the discriminant, when it's equal to 0, the only thing it means here is it has 1 repeated root. Alright, so it like bounces on the curve and then bounces straight back up like that. That's your repeated root. Alright. So, this one we can't solve. I created one that we can't solve. But it's nice to show you this, because if you do get to this point, then you should point out that this implies no real solutions, because b squared minus 4ac is less than 0, or equal to 0 actually. Yeah. So these can be less than or equal to, or greater than or equal to. Okay. And that is your basic introduction to simultaneous equations. We've got ones where we're solving quadratics, so we should be able to do that at this point. We've got ones where you have to do a bit of expanding brackets, and then you've got your basic bog standard equations to solve. So hopefully this is a good video for you to watch if you weren't sure with simultaneous equations beforehand. You will see these crop up again in mechanics, in the applied side of A-level mathematics. Again, this applies to AS and A-level. So if you're doing the AS, then this will also apply, and you will see some questions that won't be as simple as this. But you can use this idea in the applied side, so in mechanics mainly. When you might have one equation of motion and another equation of motion, you can simplify simultaneously to find the time or the distance, or displacement is what it's called in mechanics. You know, so you might see it in SUVAT maybe, see what SUVAT is, or you might see it in PMCC, in correlation, in stats. Alright, so hopefully we have covered the kind of easier questions and the more difficult questions where you need to bring in other areas of your knowledge to solve these kind of problems. And hopefully I shall see you in the next video. Don't forget to like and subscribe to my channel, because I'll be making loads more A-level math videos to come out before the rush back in September. And hopefully I shall see you in the next one. So bye for now.